questions. And he has a deadline, and he's the last one, so we need to actually make this work. Hope you had a nice lunch and nice conversations, and that you maybe met somebody you haven't met before. That would have been nice. Yeah, these two guys met each other. We will now continue with 3 more presentations, and then we will have a coffee break. And the first presentation was actually mentioned by the Swedish Transport Agency a little about, it has the title, Greywater from Ships in the Baltic Sea, Quality and Quantity. No, it's not. It should be, how large is the problem in the Baltic Sea? Exactly. Never mind. The speaker is Jeanette Mujingi, known as Jane, from Chalmers. She has a PhD in Maritime Affairs, specializing in maritime environmental management, and works as a postdoc researcher for the Greywater project at the Department of Mechanics and Maritime Sciences. Welcome, Jane. And have you put it on? And this is this one. You can point with this as well.
Okay. Good afternoon, everyone. I hope I don't make you feel sleepy because you're just from lunch. So without repeating what my colleagues have already presented, we will be discussing greywater, the quantities and the quality. So greywater from ships is wastewater or sanitary wastewater from the accommodation, from the showers, from the kitchen, the laundry machines, and various things within the ship. And it contains chemicals, nutrients, metals, pharmaceuticals, as we are going to see. And generation rates vary according to the size of the ship or the activities carried out within the ship. Greywater lacks international regulation right now, and that is the call for concern. Only until recently that this raised an eyebrow because of a lot of research that has been carried out recently on greywater. And management strategies are based on industry policies or initiatives and environmental stewardship. So greywater could be discharged directly into the sea from the ship when generated, or it could be discharged to port reception facilities at the port, and then treated at the municipalities before discharging to the sea. Some other ships, like cruise ship, mix greywater and black water or sewage together and treat on board before discharge. And research has also shown that some ships mix greywater with food waste and discharge in accordance with the provisions of MAPOL Annex 5. So our objective within the framework of this presentation will be to characterize greywater, the quantity and the quality. We will also estimate the potential greywater-borne contaminants from the Baltic Sea shipping globe as a whole. And we will look at potential hazard of some targeted contaminants based on hazard indexes, MAPO resolution, and as well the EU environmental quality standards. So within our research, we worked with six ships. One is a special purpose ship, 5 are row-pack ships. Row-pack ships carry both passengers and cars. And the S2 and S3 are from the same company as sister ships, while S4 to S6 are also sister ships. The biggest ones are S4 to S6, and we have S2 that comes after and S3. Then the smallest ship is S1. And the volume of greywater generated by these ships also vary. We see, like I mentioned, according to the size of the ship, it's based on the size of the ship. Sometimes, I mean, there are discrepancies about that, but the number of persons on board determine the greywater generation volumes. So, as the volumes also are seasonal, and they are annual. We experience annual variations and then seasonal variations. As you can see here, here, we see in 2019, these ships had the highest volumes in 2019, and thereafter there was COVID that affected the industry, and it could be seen in the volumes of greywater generated. Then they picked up again in 2022. So it varies annually. And seasonally, we see the summer periods, July and August, July to September, about September, we have highest peaks for greywater generation. This is from sheet 5, this data from sheet 5. We see 4 years data from sheet 5, and it is clearly seen that greywater generation volumes also are strongly correlated with freshwater supply, as well as the number of people on board the ship. And we also see the impact of COVID on these 3 parameters. Okay. And it is also important to note that greywater volumes could be as much as 4 times the volume of black water. So I borrowed this figure from Yao Kanen and colleagues, and to use these numbers to estimate the total load, I mean the potential load of contaminants from greywater within the Baltic shipping industry. And we see also passenger ships contributing the most. In 2022, 84% of the total volume generated was from passenger ships. And I want us to take note of this figure because we will use this subsequently to estimate the load of contaminants from the passenger ships within the Baltic Sea. So greywater, to achieve this greywater was sampled from the ships. And we actually sampled 5 ships and got 8 greywater samples. Our interest was more on individual flows because research in this, I mean, data for contaminants on individual flows, greywater flows, is very scarce within the Baltic region. So, but we succeeded. From one ship, we obtained accommodation, laundry, and galley greywater individually. And from this other ship, S3, we could get galley greywater, but accommodation and laundry was mixed. And for these other 3 ships, we got mixed flow, mixed greywater. And altogether, there were 8 samples. So the results, we will begin with metals. And why not? I don't want to waste a lot of time, so I'll just mention that the most prominent metals we obtained in the greywater was zinc, copper, and manganese. These 3 metals contributed about 95% to the hazard index. I'll mention what hazard index is of the greywater. Okay, so my colleagues have already talked about measuring hazard or risk assessment, and we use the same principle here. Using hazard quotients, we calculated hazard quotients for each contaminant, which is the average measured concentration divided by the predicted no effect concentration. And for each stream, we added the hazard index, the hazard quotients of the individual contaminants to get the hazard index of that stream. And If the hazard index or the hazard quotient is greater than 1, then there is a potential hazard. And if it is between 0, or we grade it as high hazard, medium hazard, and then low hazard. So some have high hazard, some have medium hazard, as we can see, and high hazard and low hazard. But zinc, copper, manganese, and some to an extent arsenic fell within the high hazard range. They had the highest contribution to the hazard index. And overall, the hazard index of greywater was 113 approximately, which is far higher than 1, which shows a very high potential, very high hazard potential. And in decreasing order, we also looked at the various types of streams, and the highest hazard potential was shown by galley greywater, and the lowest was by the mixed greywater. So looking at the loads of these metals into the environment, if you multiply the concentration by the volume, as I mentioned earlier, then we see that this amount, like this amount of milligrams of zinc, copper, and manganese could potentially get into the environment if all the greywater generated is discharged into the sea. Then we have nutrients. Nutrients were, nutrient concentration were measured with the resolution MEPC 22764, which is the standard for sewage from advanced wastewater treatment plants on passenger ships within Baltic spatial area. So we see for nitrogen, first of all was highest in galley greywater, and phosphorus was highest in laundry greywater. And in comparison with MAPO and with resolution MEPC 22764 standard, we see nitrogen was within the standard. It was actually below. This is below 20 milligram per liter for the geometry mean, and the phosphorus was above. So we could say that if phosphorus in greywater is compared with phosphorus in treated sewage that is expected to be discharged into the sea, then it could also pollute as much. And the average loads as well, considering this volume of greywater discharged from passenger ships, we could obtain this amount of kilograms of nitrogen and phosphorus potentially into the sea. Then we have organic matter and oxygen consuming substances, notably COD, BOD, TOC, TIC, and fat. And we see highest concentrations in galley greywater, which could probably be as a result of food waste. Food waste in galley greywater. Then we also compared it to the IMO resolution 22764, and we also found out that these concentrations are far higher than the requirement for sewage. And the same thing with the loads. We could potentially have these tons of COD and BOD into the sea if all the greywater is discharged. Then we also have TSS, which we measured, and TSS was highest in galley greywater of ship 2, and secondly in also mixed.
Could you please say what is TSS?
Sorry?
What is TSS?
Okay, total suspended solid, sorry. The total suspended solid were highest in galley greywater, which would probably be as a result of food waste. Okay. Then we have these loads as well. First of all, we compared the concentration with the requirement of the IOM requirement for advanced wastewater treatment plant for sewage, which is also very high. Then we compared the loads, we calculated the loads and found that about 600 tons of total suspended solid could be discharged into the sea, could potentially be discharged into the sea from greywater. And then we have microplastics. About 15 microplastics, polymers, were analyzed in greywater. And we see the highest concentration of microplastics in laundry greywater, and followed by the mixed greywater. But our interest in laundry greywater is in laundry greywater, as according to the literature, laundry greywater, even land-based literature, laundry greywater is high, very high in microplastics concentration. And the particular polymers in laundry greywater were PET, polyethylene terephthalate, and polypropylene. And two of them contributed at least 74% of the total microplastic concentration in the greywater. And the main source of PET is the washing of textiles, as well as the main source of PP is labeling and packaging. But PET also has packaging. We also have plastic packaging made up of PET. Studies have also shown that even our chopping boards in the kitchen made of PET can also release microplastics into greywater and food waste. And we had special concern for the polymer polyoxymethylene, which is actually used in dishwashing machines for proper cleaning. It's used on board. So two of these ships use this, but strangely we couldn't measure this sperm in the galley greywater from the ships. So according to the literature, it shows that this sperm is really high. It has higher strength and high resistance. Probably that is why it is comfortably used on board for this purpose. And we could find only a minimal amount in a mixed greywater sample, which could be probably come from other sources. Okay. And then we compared microplastic concentration we obtained from this study with other studies to be able to know how big our own concentrations could be. And we actually found out that it is within the range of other studies. Other studies are within this range, which shows that they should be concerned on microplastics from galley greywater in the same way as concern from microplastic in other sources. Then we calculated the loads, which we obtained as about close to 1,000 billion. Microplastics a year could be discharged into the sea if all the amount of greywater generated is discharged into the sea. And compared with sanitary sewer overflows, which are wastewater overflowing from a municipal wastewater treatment plant, our own greywater value was a bit lower. Then we have pharmaceuticals, which we measured in the greywater, and we see that there are particular pharmaceuticals that occur in all of these greywater streams. We will see in subsequent slides. We have the pharmaceutical, for example, caffeine, all these other ones that are above the 1 microgram per liter line are the prominent one, and we see most prominently from surfactant and tobacco and industrial chemical. Most importantly, we see that some of these chemicals have been listed in the Environmental Quality Standard Directive as priority substances, which their values, EQS values, are lower than the values we obtain in this study. I think it is something we should look at in detail. Then, what should we do with greywater? Now, what is the probable way that we could manage greywater in order to have, to minimize the consequences of these contaminants on the marine environment? So we have this Lighthouse-funded project, which we are rounding up with, which we are assessing the cost-benefit, and we are carrying out a cost-benefit analysis of alternative greywater management strategies. And we simulated 6 scenarios, which we feel some are existing, some don't exist, but they are models. And we think analyzing these scenarios may give an overall idea of how greywater could be managed subsequently. We also have this project, is the SWAM initiated and funded project, which we just began last month, on microfiber filtration solutions for onboard laundry on passenger ships. We are evaluating the technical feasibility, environmental performance, and cost effectiveness. We look forward to presenting our results in subsequent seminars like this. So in conclusion, we would say that greywater is an issue. Greywater contaminants is an issue if greywater is discharged completely into the sea. It is also important to note that our ships, our sample ships, all the RoPax ships we sample discharge their greywater into port reception facilities. So maybe further research on the actual number of ships that discharge greywater into the sea, and a proper environmental risk assessment could determine, the magnitude of the impact of greywater contaminants in the sea. And we could also say that this, greywater could be included in MAPOL Annex 4. Yeah, MAPOL Annex 4, why not? They are just the 2 sanitary wastewater with sewage that should be regulated by MAPOL Annex 4. So thank you very much.
Thank you. And you did not really meet the 15 minutes, so I don't think we have time for so many questions. Maybe just one. And thank you very much, Jane. Yeah, it was interesting. A little too long. So, does anybody dare to pose a question? Otherwise, you can talk to Jane in the pause. Yeah. Thank you very much. And our next speaker, and this is your last slide, actually, Jane. Tank cleaning on ships, insights from research. Wengang Mao, professor at Chalmers University of Technology, normally talking more about AI and at meetings we have with smart ships and things like that. But you're also going to talk about AI.
Yeah, it's also about AI.
So welcome.
How AI is used for the maritime environment. Okay, so, as we know now, our daily life and also the industry activities are very much dependent on the chemical tankers. If we're looking about the map in the Swedish coast, we see we have a lot of factories which post-process or produce these chemical products. And then why they're putting this the production in the port? Because they rely on the transport of the chemical tankers. As we see now on the map from the marine traffic, we have something like 2,000 chemical tankers which are operate along the Swedish coast in the yearly basis. And then for these chemical tankers, as we know, when they transport the raw material and also the product, and then one chemical tanker they sometimes has to transport different kind of chemical product, and then between different voyage, and then if they transport different chemical product, that means now they have to do this the tank cleaning. And then after they have done the tank cleaning, I mean, a lot, as we see now, a lot of waste can be dozens or hundreds of tons. And how they deal with this the waste. As we can see now, this is the picture which we got from the Swedish Coast Guard. They just dump this one into the water. And if you just imagine now, we have something like 2,000 vessels in the Swedish water. Maybe one vessel operates like 100 voyage. So how much chemical waste, which is just dumped into the Swedish water, and then what kind of environmental impact they can produce due to this tank cleaning event and also the waste discharge. So in order to understand or answer this environmental impact, I guess now we first need to see how to, I mean, if another case is also in terms of the discharges. We also did some kind of inventory study looking about both countries inside the Euro and also in Asia, China, and the US. And different countries, they have different regulations regarding how to regulate the waste discharge in terms when they are put in the sea. And of course now we are more interested in the Swedish water. So in order to, I mean, one question we may ask ourselves is the regulation by the Swedish water is the most reasonable in comparison with all the others. And then in order for us to have a needed more understanding about which is the best strategy in terms of the regulated waste discharge from the chemical tanker, I guess now the first test, we need to understand how much water or how much waste has been dumped into the Swedish water. And then in order to answer these questions, so we, from our side, we first want to investigate how to find when and where this discharge happened in the Swedish water. So one way to looking about this discharge event, we can of course looking about each individual vessels to looking about, as we can see now, the trajectories. I mean, without explaining too much, as we just shown this, the trajectories over there, they are not doing the transport work, just flying around. So that is now we can easily see they have something over happen over there to do this tank cleaning. Yeah, that is very easy for us to see, but we need to plot them out. And then for some cases, as we see, they are not going to this very back and forth, but they are trying to go into the outside of the economic zone and then coming back for these two different scenarios. So as we see, if they are going to the shortest distance compared with the actual distance which they are saving, which is now and of course we are not going to talk about the emissions, can be 3 or 2 or 3 times more than just forfeit the emissions. And then that is one case we can just plot this the trajectories from the ships, and we can see that they are doing the tank discharging. By using these features, we can also see when and also how many of the water they have discharged, they have been put into the sea. But if we're just looking about now in the Swedish water, we have something like 2,000 vessels, and each vessel we just count 50 voyage. So if we do this one by the manual plot, I guess now it will cost a lot, and no people is willing to do in the daily work. And then the question for us, if we can using some AI and also together with some experience to automatically ask the computer to do this task for us. So the method which we are proposed and working together with the environment is now, first now we have this AIS data, which is we get from the Swedish Maritime Administration along the Swedish coast. And then we are using our experience. The experience can be, for example, the Coast Guard. They do find some kind of discharge. And then so we can see and this discharge find some patterns from the navigation perspectives. And we also have some experience about how the chemical tanker navigate when they are discharge the waste into the water. And then with this also the experience, we can see if we can create some AI agent to looking about AIS data by themselves. And then they can give you the information what is needed about how much and when they have been done this waste discharge. Yeah, so I mean, maybe it's not wise for me to talking about the details about how the AI and also the domain knowledge. So I just want to show you some result. The first result, we're only using the AIS plus the domain knowledge in terms of the AIS. I guess all the people here must be familiar with the AIS data. And then if we're looking about AIS data, the rule is now for the vessels which they are sailing, like the cruising, they need to send us the AIS signal maybe every 10 seconds, maximum 10 seconds if we're talking about here. And, but in case for the chemical tanker, they didn't send out this AIS signal like for 5 minutes or 10 minutes or even a few hours. So what are they doing? This can be a very big suspicion about some illegal discharger. And then with this domain knowledge, we have been plot all the time interval, which is a chemical tanker sending the AIS data to us. And as we can see here, and for all this, the AIS signal, which is we seen the time interval more than 5-10 minutes or 50 minutes, and then we just plot this the blue dot. So that is something happened around here. And then with this information in hand, we can just handle these trajectories to people who are interested to investigate by automatically detection. Yeah, that is one, we're using the domain knowledge regarding the time interval. So we need to receive the information like every 10 seconds. And then if they didn't send out in 10 minutes, something happened. Yeah. And then another domain knowledge is now, you see, for a lot of ships, they have sailing a lot of distance. Like one we can show here. They are going from here to here. But then they have sailing a lot of distance, but they are not doing the actual transport work. And then for both this case and the other case. And another case also, some of them, they can have a very sharp turning in terms of change of the heading angles just within a few seconds. So by this way, we can see this also some suspicious behavior we can define, and we can give you this AI agent. By doing this way, and then they can also help us. The AI can help us to, let's say, find all these suspicious trajectories. So after we have found all these suspicious trajectories, that is now another product which we produced in this project, and we put all the trajectories in the visualization platform. So within this visualization platform, if you click any of the route, so they will pop out what is now the voyage ID, what is now the IMO number of this vessel. So you can see which vessel is doing this kind of event. You can also see how long time they have done this discharger. By this way, we can also have a very nice way to be communicated with the expert. Is this guy is doing this illegal or legal discharger in terms of if they are outside of the economic zone or is inside. Okay, so and that is now some result. We are using you see, the only information we are using here is the AIS data. But then if we are looking about how the captains they navigate these ships, so in addition to the AIS data, we do also have many other informations like the bathymetry of the navigation and also the coastline. And sometimes also the weather conditions will be also different. So can we also take into account this kind of parameters in the anomaly in the detection of the tank cleaning? By doing this way, it will be not simple as we are doing in the engineering or in the feature engineering. So we need a little bit more advanced AI agent. Like now, if you heard about what happens in the automotive engineering, it's now the image recognition. Yeah, so in terms of only using the trajectories, so we are trying to create the image And the image can, of course, now the first layer is now also the trajectories. But in addition to the trajectories, we can also give the information. And for example, the other layer, like we see the coastline along the Swedish coast, we can also give the information about the bathymetry. We can also give the information about this economic zone, and also about the wind and the wave, all these kind of informations. And then they will put all of them together to convert into an image. And then with this image, so this contain all the information about the navigation of a chemical tanker. With this information, of course, we need to create another AI agent. So instead of we are looking about the image, the computer, they can look about the image by themselves. And then by this way, they can cluster the image into different groups. Of course, what we are interested in now, we are interested in this very strange behavior. And then by putting this AI agent in this, by putting this AI agent to check about this the image, and they can help us to get all the out layers from the chemical tanker, from the sailings. And then with this information, as we see, some of them we see, if we're looking about this one here, this one is treated as an outlier, which means now they have done the tank cleaning. But if we're looking about you see, they have some kind of land or the coastline. So this is now, if we are a human, because this is now given by the computer, by the AI agent. But if we are looking about this image by ourselves, which we have some experience, we see this is the normal trajectories. And then how can we handle this case? And then in this AI or machine learning, we have another methodology, which we call the active learning. So by the active learning, that means now here we have given this a lot of outliers, and then we click each of the outliers, and then we have using the humans to check if this one it is a real outlier or not. And then we feedback with the information to the agent. So eventually now, we think the result is very promising. We just got from yesterday. So that is now the two very good examples which is come out from the AI agent. I mean, if we are looking about just the trajectories of the vessel, like the red lines, both of them are outliers. So they are doing very strange transport. But then on the other side now, the AI agent, they told us on the left-hand side, it is outlier or it is a strange behavior. But then they told us also here is regular. Do you know why? Yeah, because the AI agent, they can already see now they have some land. The vessel has to go around in order to be safe. So that is now some kind of big success for this product which we have been developed. By giving the input or the feedback to the AI agent, now we can have another new set of the outliers, as we can see here. That is now automatically detected by the AI agent. And we can all basically now see most of them, I mean, they are very, very strange behavior. So we can feed this information to the people who are interested to know when and how much of the waste discharge come from different kind of chemical tanker. Yeah, so that is now the latest result which we have from this research project together with Ida. And then in the end, our final goal for this transport agents administration funded project is now we will create this AIS data. So everything before is now the pre-trained. And we want to make this as a real-time monitoring or real-time detections. So we can put all this AIS data in the database, and then we create also like the mid-ocean conditions and bathymetry data and historical data from different kind of chemical tanker. Then we have our own AI agent to detect all these anomalies, and we show them on the user interface, not QGIS, for the real-time detections. I guess now if some of you are interested in this one, everything which we have been done is published on the open GitHub. So all the code is free accessible. Thanks.
Thank Thank you. Interesting way of combining different disciplines. Any questions to Wengang? Clear as crystal. Okay.
Yeah.
Thank you.
Good. Thanks.
I could have asked you some, but we have to keep the time, you know. And Roland is our next speaker, because you're going to talk about everything that everybody has been talking about together. Shipping's footprint, hazardous substances in the marine environment. And you also come from Chalmers. PhD student. And you did your bachelor's degree in coastal and marine management in the Netherlands and master's degree in marine science in Sweden.
Exactly.
Welcome.
Thank you. Yes, hello everyone. I'm Roland. I'm a PhD student at the Division of Transport, Energy and Environment with supervision by Ida, Maya and Eric. And basically the focus of my work is trying to tie it all together. So I'm trying to have a holistic assessment of the effect of liquid shipping discharges onto the marine environment. And this figure might look slightly familiar to you by now. So as you already heard from a variety of presentations, there are a large variety of systems on board of a ship which produce a large variety of emissions or discharges. Usually we call it emissions if it's to air and discharges if it's to water. And based on the operating condition and the origin of these discharges, they also differ in properties. So that is something you need to take into account. Within our project, we focus on these 6 waste streams, we call them. So antifouling, ballast water, sewage, greywater, scrubber water, and bilge water, more or less all of which you already heard about. So I don't have to spend too much time on those. And the project itself was initiated by Havsakvattenmyndigheten, and we focus on the OSPA area, which you see there in red. It's basically the Northeast Atlantic, and it falls under the OSPA Convention, which is an agreement by the, I think, 15 contracting parties to try to avoid marine pollution and negative effects on the marine environment. And we focus on the years 2018 and 2023. 2018 because after 2018 we saw a lot of increase in scrubber installations, so we wanted to have a reference point before that. And 2023 because it was the last year where we had a full data set, and also we wanted to avoid introducing bias due to COVID-19, so we didn't choose a year before that. As you also already heard, regulation of the discharges from shipping is usually either based on substances or based on waste streams. So it's not a very comprehensive approach. Usually you regulate one waste stream at a time. So for example, releases from antifouling paint are covered by the AFS convention that Eric already talked about, and also the biocidal products regulation within the EU. Ballast water is covered by the Ballast Water Management Convention. Sewage is covered by MARPOL Annex 4. Greywater, if it's mixed with sewage, for example, is also covered by that. Scrubber water is covered by MARPOL Annex 6, but also you have these local regulations that we already heard about, for example, the bans of open loop scrubber discharges in territorial waters. And for bilge water, that is covered by MARPOL Annex 1 about oily discharges, but again, you also have local regulations. In that case, for example, you're not allowed to discharge oily water in Finnish territorial waters. Oops. Now, we heard a lot about why, we heard a lot about that it's important to have a holistic approach to this, but why is that actually? So you have this thing called mixture toxicity. If you imagine we look at a water body and we sample a number of substances, for example, and for each of those substances we have a threshold value from the regulation, for example, that says the values need to be below that level. It could happen that we measure each separate concentration for each separate substance, and all of them fall under the respective safety threshold. So the threshold would actually be different for each substance, even though I drew it as one line here. But then if you do what our colleagues at IVL, for example, did, you run a toxicity experiment on that water, then you might actually find out that the overall toxicity is actually above, or you see a toxic effect. So even though every single substance is below the safe threshold, the combined effects that also Mia mentioned can be quite severe, even if every substance is below the threshold. So we need to take into account this effect of mixtures and take into account the different sources and the different streams that contribute to this overall toxicity. Now, how do we do that? You also heard about the STEAM model, the Shipping Traffic Emission Assessment model from the Finnish Meteorological Institute. So from them, we get data on the volumes of the discharges as a gridded data set, basically. So for 2018 or 2023, we get a map like this, where we see for each grid cell how much, for example, ballast water was introduced into the system there. And it's based on AIS data from ships and also on the characteristics of the specific ships. For example, what kind of engines they have. And also, I think it also takes into account weather information. Then we also have information about the concentrations of different substances in those waste streams. And as Jane already said, for example, you calculate the load by basically multiplying the volume. So you have, for example, 500 liters of a specific waste stream. You multiply that with the concentration of the substances in those waste streams, and then you end up with the load. And in addition to that, from OSPA, we also have loads of metal inputs from rivers, riverine inputs, and direct discharges, which is, for example, industries that are on the coast that release as a point source. Now, the results from that look like this. On the top, you see the direct discharges from coastal industries. In the middle, you have the riverine inputs, and at the bottom, you see the inputs from shipping. And the light blue boxes are year 2018, and the dark green boxes are 2023. And you see copper and zinc are basically dominating in all three categories. And you also see that direct discharges and riverine inputs overall, in terms of metal, have a larger load. But you also see that copper, for example, from shipping, actually overtakes the inputs from riverine input and direct discharges combined between those 2 points. So at some point between 2018 and 2023, copper loads from shipping actually overtook those from the land-based sources. What you also see is that the inputs from shipping generally increase. So for the shipping, at the bottom you see the dark bars are always higher than the light bars. For the riverine and direct discharges, for almost all substances, they decrease. So you have opposing trends there, so to speak. Now, if we focus or zoom in on shipping itself, we see again an increase everywhere. The dark green bars are the 2023 values, the light green bars are 2018. And the largest load, again, are copper, zinc, and then you have isocyanuric acid, sodium thiosulfide, vanadium, nickel, some more metals. So those are the 15 largest loads that we see in shipping. But we're interested not only in what are the biggest loads, we want to know where do they come from. That's the entire idea of this holistic approach. So if we check where those loads originate from in terms of total load, we see that the largest load, again, is copper and zinc. And those originate to a large extent from antifouling paint or from the releases of substances from antifouling paint. Then we have ballast water. CI means chemical injection, and ballast water EC means electrochlorination, as Anna already introduced earlier. So those are, in total, ballast water is the second largest contributor in terms of loads. And then we have open loop scrubbers at the bottom, who also contribute mostly vanadium in terms of loads. So these are the amount of substances that we see as an input. As you also heard, we are not only interested in the amounts, we're interested in how toxic it is, how to assess the toxicity or the potential toxicity. And one essential thing that also was introduced by Anna and Eric is the risk quotient, or it was introduced as risk characterization ratio by Anna, for example. So you have the measured concentrations and you have a specific threshold concentration that you consider as safe. And if you put those two into reference and the resulting number is higher than 1, so if the concentration exceeds the threshold from a risk assessment perspective, it's an unacceptable risk, so you don't want that. But, as Jane also mentioned, we have to multiply this by the volume in order to take into account how much of those waste streams are actually exiting the ships or being introduced from ships. So we multiply the risk quotient of each substance by the volume of the corresponding waste stream that it comes or that it occurs in. And then what we can do, we aggregate this across substances on different levels. So for example, we can aggregate this all together and then get what we call a hazard index, for example, for different OSPA regions, or we can sum it across different waste streams. So we can compare the contributions to overall toxicity between waste streams, for example, or between regions. Yes, I don't know why that had a separate animation. If we look at the hazard index, now we're talking about potential toxicity, so to speak. The light boxes this time are 2023 and the dark boxes are 2018. We still see that it's dominated by copper, but what comes next changes. So the toxicity or the intensity of toxicity is not representative of the load. So even though you have substances that are not that high in the loads, they still show up relatively high for the toxicity or for the hazard index. So while copper is still top, we have pyrithione, which also comes from antifouling paint. But then we see endeno 1,2,3-CD pyrene, benzo K-fluoranthene, so a bunch of PAHs. Then we see some metals again. Uranium we see, which mainly comes from scrubber, from one ship, from a measuring campaign, which is not really something that we expect to see in scrubber. So in that case, we think it's probably to contaminate, or could be due to contaminated fuel because it was only in one measurement campaign on one ship. But similar to the loads, again, we want to know what contributes most to this toxicity or to the hazard index. And again, antifouling is a large contributor, but you see that copper is not so dominating anymore. So the toxicity is disproportionate of the load. So this is something you need to take into account. And scrubber is a close second in terms of contribution to the hazard index. And if you remember from the graph before, now the scrubber box is much higher. So the toxicity of scrubber grows faster than just the load, which is an indication that the substances that are driving this toxicity are quite toxic, actually, which you can see here. So, for example, these PAHs that I just mentioned, they are showing up here in the largest boxes. So they are the main drivers within scrubber water that drive this hazard index. Now, if we only look at the increase, we see what drove the increase in toxicity, then it looks like this. So the increase in toxicity or in hazard index mainly comes from scrubber, and then antifouling suddenly becomes the second. And this is due to two factors. You have an increase in shipping activity overall, which is why we see an increase in every single waste stream in the loads, in the hazard index everywhere. But between 2018 and 2023, as I said, we also saw an increase in scrubber installations. So this is a combined effect of both increase in shipping activity and increase in scrubber installations. So, what do you take away from this? Basically, the land-based metal contributions were large, but they are decreasing, while for shipping, we see the opposite trend. So shipping emissions are going up, or discharges are going up. And the largest footprint are from antifouling and scrubbers. And scrubbers, as I said, contribute a lot to this increase, so they are actually catching up fast. And potential solutions to this would be cleaner fuels or alternative fuels, entirely different types of propulsion, and also the biocide-free antifoul or the biocide-free foul release coatings that Eric already mentioned. And again, because the mixture toxicity of these cocktails can be so much higher, it is important that the legislation also takes into account the overall inputs and not just looks at single waste streams or single substances, because then you might very well be under specific thresholds, but if you look at it overall, you might still observe an effect that you don't want to see. Yeah, thank you. And thank you also to... And also thank you to my supervisors and co-authors, which you can also see up there. And the project was funded by Trafikverket, and it's part of, the work is part of multiple projects.
I think this was an excellent summary of all the other presentations, actually, putting it all into
I hope so.
a good context. So, do we have any questions to Roland? What's the next step in your work?
Finish the manuscript.
Okay. And when is that? Due?
As soon as possible.
Okay.
Yeah, that's a good question. I mean, first of all, now we want to get this manuscript out of the door, but then we also we are starting up a second manuscript where we look, so this was the OSPAR, had the OSPAR focus, so Northeast Atlantic. But next we're also looking at the Baltic Sea, have a focus on the Swedish coastline with a model developed by SMHI actually, which is going to do similar things as the STEAM model. But we were involved in customizing it and developing this, the implementation of the discharge modeling. So it was kind of nice that we could have an input on how to develop this model. And then we will look at smaller administrative units, I would say, to compare how, for example, the environmental status is in these small vattenförekomstregioner along the Swedish west coast. So a more, sorry? And the costs, exactly. We also, yeah, that's the ship cost project actually. So in that project, we're also trying to put a monetary value on the damage that you're causing. So, yeah.
Anything that surprised you in your work?
Well, it is quite impressive that shipping had a larger impact than all the rivers in the area. But no, I think I heard a lot about those things, so it was kind of an expected result, to be honest.
Okay. You were not happily, there was nothing that was better than you thought then?
Well, I mean, I mean, to a degree, we are starting to see regulation of, for example, of scrubber discharges, so I think that's a good thing. But as I said, it is essential to have this holistic approach and not go on a waste stream by waste stream basis. So it's definitely a step in the right direction, though.
Okay. Any question? And Sven Borén, Blekinge Tekniska Högskola. And if you would like to comment from Transportstyrelsen, you're very welcome.
Thank you for this nice presentation. I was wondering about in this OSPAR area, are there known thresholds for different species when it comes to copper, for example? It would be interesting to see that how these results relate to that.
Yes, I mean, we do have threshold values, and it depends a bit on what is available. So if we have, for example, a regulatory value from, for example, the Water Framework Directive, that is, for example, something that we prioritize for copper, for example. So, and in order to calculate the hazard index, you do actually need this kind of threshold value. So if you don't have that, which actually happens for a bunch of substances, you don't have a PNAC value or you don't have a value from the Environmental Quality Standards Directive, then you cannot actually calculate the hazard index. So that is also a data gap, basically. So we don't have threshold values for every substance that we have concentrations of. And we don't have concentrations of all the substances that we see in the waste stream. So it's always better to have more data.
Okay, so have you also recognized thresholds for the cocktail effects for different species, or? Because you put it all together in like that.
No. Well, we don't. No, that's a good question. We don't do that. But then, for example, that would be a good approach to combine with the ecotox experiments, for example, where you have full effluent toxicity measurements, and then you can say, okay, the PNAC value is 0.0001 or something. Oh no, the LOEC value in that case.
Okay, thanks.
Thank you.
Thank you. Any more comments or any more questions? The comments you can take aside. Any more questions from anybody?
No? Thank you.
Then I think we should give all the researchers that have been presenting a big applause. And say thank you very much. And now you will be served coffee, and then we will have 2 speakers left coming from industry. And now you know everything about everything, so you have to maybe change your presentations or maybe add something, I don't know. Well, welcome back here at 3 o'clock. for being still here, so many of you. And we now get to the part where actually Claes takes over the scene. We have the theme industry. You took away my slide. It's okay. So we will now hear from Tanker Shipping Company. How do you approach the marine environmental impact and regulatory compliance? And Claes Gustafsson, he comes from Furutank Rederi and is working there since he was a small boy. Yeah. On board and then ashore. And he's also part of Lighthouse Program Committee, actually. And welcome, Claes. The floor is yours.
Yes.
You need also to have this one. Yeah. No, I didn't say. I'm sorry. Not the other way. Yes, because we are broadcasting all over the world. So.
Yes, I represent the one that cause all these things and shall then try to comply to it also. I come from Furutank. We are a family-owned tanker shipping company basically from Donsö, outside here. We have built vessels since 1954, the one up to left corner there. That was one of the last vessels that was purpose-built for Göta Canal. So it is fit to the locks there. And at that time I was not present. I started with this vessel here. So I have been involved in building 3 generations of tankers. And at the moment our main business is that we operate a tanker pool. So we operate in-house 27 vessels from these different ship owners, where we have a majority of the vessels. But pooling, and we have 5 vessels currently in order in China that will be delivered from next year until April 2027. And the purpose to do like this to pooling vessels is that we are operating in the spot market. That is our main business. Then we have some vessels on time charter. When you have a vessel on time charter, you rent out the vessel to a customer that use it how they like. But if you pool, running vessels in pool, then you try to minimize the ballast legs, that you try to find as much as possible of triangle shipping that you can minimize, that you maybe have only one leg that is ballast, and in that way making more money for everybody. And we are the biggest operator in our segment in Europe. We operate, and the segment we are calculating is 15,000 to 20,000 ton deadweight. That is a normal size for depot distribution and also trading business in Europe. And the vessels is about 150 meter long, and they are about 20,000 cubic meter of cargo. And all this we have talked about today, so I don't need to show it. But this is, if we talk about environment, this is what we should comply to. And some of these things is a little bit, as we saw here today, that zinc is one big polluter in European waters. Why do we not have same as US with the vessel general permit, where it's not allowed to have sacrificing anodes of zinc, for example, that have been easy to adopt in Europe? Also that we don't allow, in US is not allowed to have mineral oil in any oil to water interface. And most of these things are quite easy to adopt to. The one that is more complicated, it is national regulations in different places in the world, and also customer requirements, but because that can be whatever. All other things is quite easy to forecast and develop to. And how do we do this? We build new ships. That is a quite good way to adopt and future-proof the business. And the hard thing is that you should also future-proof for 20 years forward when you build a tanker. And all these features we decided when we built the vessels to be, most of them is above legislation, that we are better than what we need to be in compliance. But many of them costs extra money when you build, and you, in some way, you want to have a benefit in this way, and one way to have a benefit is that you get lower port dues or fairway dues, or you get better, that you get a customer that are interested in these features. And when we started with this in 2013-14, the main customers that was interested in environmental improvement was the Nordic oil majors like Neste, Preem, Equinor. But during these years, that when we have built the vessels and have them delivered and out on the market, we can see an increased interest from also other European oil majors. And we have also built up a totally new business with these vessels from a small decision we took when we ordered the vessel. There was quite good in size. It started when we looked on Södertälje Canal. That is not finished yet. Maybe the vessels are scrapped before it's finished. But we started to look on Södertälje Canal, and then it was easy to go over to another canal. That was St. Lawrence Seaways. And we added that to the specification, which means that we need to apply to VGP for US and then some other features for the canal, which afterwards built up a totally new business for us. So now we employ at least 2 vessels every summer in Canada. And we started a cooperation with a Canadian company that is part owner in 10 of our vessels we have ordered. So small things can have a big impact in the development. But of course, one of the biggest things is CO2 for us today. It started with NOx many years ago and went over to SOx, and now everybody is only talking about CO2. And this is one thing that we did also with these vessels when we built. We was with the noise. That is not a requirement yet, but it is a requirement in many ports, especially on the continent, but also Brofjorden, Preem Brofjorden. They continuously measure noise from the vessels from fixed measuring points. And if you make too much noise in the port, you get a protest. And if you don't do anything about it, then you're banned from the port for 6 months or something. And that is due to their environmental permit, for the refinery. But when we shall do this involved that we shall have the big silencers on the fans that is 3.5 meter high. And we should install this somewhere in the ship, and the shipyard was very confused about this. They said there is no other ships that have this. Why should you install this one? Very big. And we said that it's needed because it is people living close to the ports and so on, they're complaining, so we should have this. And then the Chinese guy looked at me and said, so you mean it's impossible to move the people? Yeah. But then we come to CO2 targets, and this is the development in our fleet since 2008. And it started, first this started off, if you see that 2011, then we had the Lehman crash in United States and the tanker market went down in rock bottom. I think the levels was that we had saved $4,000 or $5,000 a day if we laid up the vessel instead of sailing. So we was forced to do something. Then we reduced the speed, and that this speed had never come up again after 2011. It's still on the same level. Then we did other technical improvements on existing vessels and come down to this 2014 level. And then we started to invest in the new vessels in 2018. And we come down to the level shown there. And after that, it's very hard to find the big steps as it looks now. But then we come to this blend, shore power, sails, other smaller, other energy savings. But when we, this is a little bit old, this graph here. Actually, this today, it looks like this, maybe like this. It goes straight down here because we have changed over to biogas on all vessels that is gas fueled. And this is due to Fuel EU and trade of ETS. So we can sell our surplus, that we CO2 surplus that we get from the biogas. Then it is shore power. I think it is 3 ports in the world today for tankers. Gothenburg, Gävle, Long Beach, that have shore power. But we took the decision to install this in the vessels that was delivered in 2021. We started. And that was also this that we talk about future-proofing a vessel. That you, and many, when you come to many ports, they talk about how do your business case looks for this. There is no business case in this, as in many other things we do, because you choose if you should do it or not, and then you hope that it should be good. Many times it's a little bit, it's not so much science again. To do it, because you have many things. You have one chance to do it in a vessel. It's same as all these ships they build that they are ready for all kind of things. There will never be anything about that. It's just on the paper, because it's not so easy when a vessel is delivered to do 2 big changes. It's very, very expensive and takes very much time. And to do this, when you build a new vessel, the cost is not so much if you look over a 20-year period. So our fleet of vessels equipped with shore power looks like this. I think we have most tankers in the world with shore power. I don't think it's anyone that have more vessels. So we have totally 16 vessels in 2027 with high voltage shore power connection. Then we have a little bit about this with responsibility for the different reporting and cost for the CO2 trade, which the goal is this all the time, that you should get the cargo owner to pay for the cost. That is not so easy always. And then you have the also, for us it's quite easy this, because we are often both dock holder and owner, but for most of the vessels in the world there are different. The vessel owner is one and the dock holder is somebody else. And the commercial operator is maybe a third one. And then we have started a separate company today. They were pooling CO2. And the benefit with this is that if we have a vessel that have a lot of surplus of CO2 rights, then you can sell that to the others that have a minus on the CO2. Then they can sail for some time more without doing any maybe expensive technical changes on the vessels. Then they become like this. Yep.
Thank you. You don't. Maybe you get a question or two. So maybe you get a question or two. I don't know. And what are you showing there on the picture?
This is New York. One of the vessels that have been to Canada, and they had a voyage from the lake somewhere up in the river. That was quite long into the inland on the Hudson River. And then this is on the way out before they have the voyage over to Europe again.
Okay, thank you. Do we have any questions? Yes, Henrik Palm,
Thank you, Claes,
Transportstyrelsen.
for an interesting presentation. One question, how is the market for LBG?
It is good. I think it's quite hard to find today. So they are struggling. We have one person that works full time with this, to source LBG and to sell the surplus CO2.
Liquid biogas, that is.
And the future outlook, do you know something about that?
No, but if it is a market, then it often get better, but the price is going up also. And it is mass balanced LNG we run on. So we have made a agreement to buy a certain amount for this year, and it's already, I think it is finished also for 26, 27. Also we have agreements.
Okay.
Thank you very much.
Any other questions? Erik Fridell from IVL. Kan du ta han på vägen kanske?
Okay, so you don't know my question yet. No, I have a different question. You listed all these policy instruments in the beginning that you live by, and I just wonder which of those are most difficult or most expensive for you to meet?
One big thing that we work with, Erik, it is methane slip that we're looking into all the time. Because that is one of the negative impacts of gas-fueled engines that we always get against us when we talk about our vessels. So that is one topic that we are quite ready to put quite much of effort and money to solve, that we are looking into all the time. And then other things that you can say with vessels generally, that I can say that we made a mistake. Everybody make a mistake. Nearly everybody. Everybody I know, I said that. It is, for example, ballast water treatment. When this comes as a regulation that we should install this, then we install one, because everybody do that. We have one. Then we look over the market, and I think we buy the best on the market, but we still only buy one. All other important things on a vessel, we have two. So that is something we're struggling with every day, because if you take short sea trading, you have a lot of ballast water operations also compared to more ocean-going shipping. And ocean-going shipping, if they have a fault on the ballast water treatment, then they can always do an exchange when they come out on open water. Our possibilities to do a ballast water exchange is very limited. And if we do so many operations with this equipment, we get fault on it. So that if we should, next generation ships we build, we will have two, same as with the ballast pumps. We will have one double ballast water treatment plants, for example.
Okay. But you will not be able to do that with the ones you're building now?
Aye.
Okay. Mia, did you have a question, or are you happy? Okay. And Fredrik Lindgren from Swam.
Thank you. Also, thanks again for a nice presentation. We have heard a lot about today of antifouling paints and copper. So how do you go about that in your company? I saw that there was some description about antifouling paints, but I couldn't interpret it really, what it really meant. We are
doing tests. We have had one vessel with pure epoxy in the bottom, and there we had a lot of problem with barnacles, that we have to blast away the barnacles. Then we took the decision that we did a test on one with a Canadian graphite-based hard coating on that vessel. First we did a test area and sailed for 1 year, and then last year we took the decision to paint the complete vessel with this coating, and had it dry docked a couple of weeks ago with quite good result for barnacles. That there was barnacles on the vessel because they're lying still in the summertime, but the barnacles was that you just can touch them, then you get also everything off. So it was very easy to clean. But some other, we can see that the one side of the vessel was quite affected by sun. That is one. And then we have one vessel with copper-free antifouling that we have very good result on, also for fuel consumption.
Is that one of those then silicone-based paints that you're referring to?
No, it's not silicone-based. It's the ordinary self-polishing antifouling without copper. Okay. But I don't know which active ingredients. I should send that to Erik.
Okay,
so
thank you.
Can look on that one.
Okay, thank you very much. I think we need to continue. Thank you very much, Claes. And now to our last speaker, who also works with ships in the water and other things. How does a port address the marine environmental impact of arriving vessels and its your own operations as well?
Yes.
And it will be Jan-Erik Andersson, who I actually have hired at the port of Gothenburg once upon a time.
I'm still grateful.
Yeah, and you have a new title, I saw. Don't even remember it.
We always change titles
yes,
and so on.
Head of Business Area Energy Operation.
Mm-hmm.
And you have been working on board ships and also at the SMA and
yes, the captain.
port since plus 10 years. 15
exactly.
maybe.
Yeah, something like that. Thank you for a good presentation, and thank you for being able to come here and talk to the port. We are, so to say, the interface between the shipping and the shore side, and we try to have good cooperation with everyone. So that's kind of things we're struggling. Let's see if we can. So, this. So, and I need to say this, that we are the largest port in Scandinavia, and here's a nice view. And today I just have 50 minutes, so it's a tough thing. But I will try to just make an overview and tell you a little bit about what we are doing in the port. And in these environmental permits things and impact from the operational point of view from the port. And today focus is on water, so that's what I'm going in for. But we also have these environmental permits, and it's for the water side. And also one thing that's very important for us to have these operating regulations, like Klaus, where there you talk about that. We try to do this in an international way as far as possible. So we're looking to different kind of companies and so on, and see so we can do it in with this regulations international wide. And also one thing that we are really up to our mind now is this PFAS reducing work. I think almost every one of you probably know what that is. And we are surrounded with it everywhere. And it's a pretty tough thing to deal with. But it's possible. And we have a lot of discussions in the port and with authorities and companies and so on. So, but it's important for everyone. And a quick view at our environmental permit. We received that in 2011, but with the final conditions it came out 2015. And these are things that we need to comply with all the time. And the authorities come to us and look that we do it in a good way and a proper way. And sometimes also the big oil companies come to visit us, do the vetting inspections, so they also can see how we deal with the shipping and the jetties, bollards, loading arms, pipes and everything. So that's really interesting. But yeah, see this OFA, it's oil polluted water into the shore side. If we look into this stormwater, like we say, dagvatten in Sweden, now we will get a little focus now on the energy port, because there is most of these things related to with we take up if the boat the shipping coming with slopes and whatever, and also from the shore side we have these different kinds in the area around the oil companies where the storage are and so on. And like you see here, it's a control basin. We have 3 control basins in the area, and so the catchment is different places, different areas in the harbor, and it's gone by piping into these places. And there we can check it up and see if there is any pollution, oil or anything like that. It's a possibility to deal with it and take care of it. Because we are very careful, so if there is oil spill or anything, it's really important to take care of it and in some way stop it from going to the sea. It's very important for us. And also we do this analysis on these water systems regularly, and it sounds like someone is knocking. So that's important for us to see how this water how is the quality? If it's going to be better or worse, or if there is some leak, or sometimes there can be a leak at an oil cavern, oil cistern or something that you don't see, but you maybe can see it in these systems, so it's possible to take care of it. And if there is deviations, then we need to report it to Länsstyrelsen, so County Administration Board, and it's very important for us to have good cooperation also with authorities. It's really important. So in some way we can go hand in hand and be aware of our environment. Just a small thing about PFAS, because we have put a lot of hours the last month in this area. But I think our port is like many other ports. It's old areas that have been port for a long time. And there have been a lot of different businesses, and sometimes you have fire drills and so on to these foams you have put out to see how it acts and so on. So a lot of things have been happening in the port area over the years. And we are now mapping this PFAS 11 in the energy port area. And so that's important for us to see where do we have these places that is polluted with PFAS. And we also look upstream. Is it possible to locate some locations where we maybe can take the ground, the soil, put it away and clean it, or in some other place or whatever. But now we have an ongoing project to in some way build treatment system in control basins to take care of this PFAS. So where the water coming from different areas in the port and goes to these control basins, and then it goes into some kind of filter arrangement and then out to the sea. So and then it's cleaned. So that is a project that we have been started up. And here you can see in this where we have tried to put a picture that you can see that it's some small oil residues. So it's possible to take care of. And then wastewater and slop from the shipping. It's important for a port to be able to take care of this. And it's necessary for us to accept almost all kind of waste that the vessels need to dispose. And yeah, there's a lot of things with how to deal with it. Because like Claes said, the ships, they want everything so cheap as possible. And it's very important for us also to be able to be efficient. If we will have the shipping, it's very important for us to be efficient and don't take too much fees for the vessels to come to our port. And also, we also try to do this to, in some way, use the EU waste hierarchy. So, yeah, working in move waste as far up the hierarchy as possible is some kind of really good thinking, and but it's possible, and we try to do our best to make it as good as possible in that way also. And then also Claes talked about these new vessels, new technology and so on. We also think that that's very important for our case also to try to use the new technology. And digital port call and just in time, that's two things that we have been working with a lot and still do. And let's see if this is working. Oh, very nice. So let's see. Great. Yeah, so digital port call. I think probably a lot of you have been heard about this, but we think it's important to try to, in some way, be as transparency as possible, but also be able to share information. Because in a port, it's always a very tricky part with the information. Okay, when will the ship arrive? When will it be ready? When will the discharge start? When will the loading start? When will that be ready? And so on. And if we can build systems as transparent as possible, then you can go into this system and get this information. And then you don't need to call everyone. Okay, I think I call Sjöfartsverket, the pilots. I think I call the oil company. And so if we can share the information and receive it, so we can come as close to the source as possible, that's a good way, we think. Just in time, that's I think that's been a word in the industry for many years, but now we also try to use it more and more in the shipping. And the main thing with this thing is that, like it is today, because the agreements and so on, it's pretty old in our business. So today, an oil tanker maybe that will come to Gothenburg and do the loading, they come with full speed and put the brakes down and drop the anchor, and then you need maybe to wait 2 or 3 days. So there we see that if you can make that process a little bit more efficient and use this virtual notice of readiness, you can adjust your speed so you are saving bunker and saving the environment. So everyone is happy. But it's a little bit struggling to make this new agreement, and it's and also what's necessary in this part is that you in some way trust each other. If you give a time, you put a time into the sheet or everyone, everyone is trusting that. That's not so easy that maybe it should be. But we have been working with this for a long time, and also find out systems to deal with it, and also be able to see when the shipping is coming and so on. And Claes also talked about this before, but this OPS for tankers, shore power, and here you can see it. We have built that, and we are one of the first harbors ports in the world to do this. But we think it's important for the future, and we also see that it's very efficient. It's a very good outcome of this installation. But like Claes said, we maybe not get the money for it, but we think it's a good thing for the environment to do this. The tankers, when they are connecting, they can stop the auxiliary engines, and it's very silent on board. And also in the area around and into the sea, it's very silent. So we think that is a good thing for the future. And also, as you see here, it removes a lot of these particles and so on from the area. More actions from our side, just also a few things that we have something that we call green bunkering concept that we have had for a few years, many years, so to say. And it's also a concept and some kind of regulation that we have for the bunkering industry, bunkering operations. So if they will come to Port of Gothenburg to do bunkering operations, they need to apply to this, and we do a certificate for the bunker barge. And there is education for the crew, and it's equipment that be needed on board to deal with if there's a spill. And also third-part inspection of the vessel to see that it's okay with the important things on board. We have staff, port staff on duty all the time, do rechecks and going around the area. They are checking the seaside and checking the shore side to be able to see if there is any leakages, some damages, or whatever. It's very important from us. And also, we have been talking about scrubber waste. It's possible to put that into shore, into Gothenburg, but yeah, maybe it's not so long time. We will see how the future will look like. And I think I managed 15 minutes, Åsa.
Yes, you did. Yes, you did. Thank
Yeah.
you. And you're actually the one who's a little in a hurry. Could you just go back to that picture?
Which one?
You had? The one just before.
That one?
This one, yes. And some of you know that is 510 and 511.
Mm-hmm.
And when I used to work there 15 plus years ago, all these pipelines, they were below.
Exactly.
Because that's how they built it earlier. So if there was any leakage, you wouldn't see it and it wouldn't affect the concrete.
But you wouldn't fall out over the pipes either.
No. So there's a lot of work that has actually been done to...
Yeah.
Will there be OPS on that as well?
Probably, I say. Probably, yeah. So we think it's good. And like you see here, these loading arms, it's a very good thing with loading arms instead of hoses. But some places we can use it, but some places not possible.
I can tell a little story about those hoses that were there. Well, we had the discussion in the port this was when I worked there, and said we wanted to have loading arms instead because these are not in any way up to the task. I said, well, there must be others that have these working, and your predecessor, Lennart Pettersson, he said, well, I've seen them on Malta in 1972.
Yes.
So we were like the only ones that actually had this type of configuration.
Good example, yeah.
Yeah.
So
do you have any questions to Jan-Erik? Any? Okay, Erland has one, and I will ask one on the way. You have CSI. You're using that for your harbor use, are you?
Yeah, we do. We do.
And can you see developments that would make the ships, cleaner, or the things that, for instance, Claes talked about, no mineral oils and things like that?
Yeah, we as a port, we are open to discuss some kind of new things about these incentives. For example, when LNG was coming, we did an extra rabatt on the harbor due. So yes, because the system and the index is not good if you can go into the roof, because like Claes said, if you do good things in some way, you should be able to get some good about it from the fee side also, I think. So
could you use the microphone because we're broadcasting, and you will get your question, Erland.
We request shore power in every port we come to, and if we don't, then everybody answers no, of course. Then we send a protest in every port just to get some track on it and some maybe some political pressure.
Great. It's good when the force is coming also from the market, not only from the policy makers. So it's great.
Yes, thank you. Very interesting presentation, and happy to see how Port of Gothenburg are working on environmental issues. My question is related to ballast water management, because as we heard here from Furutank, that especially ships within the Baltic Sea and shorter trips in the North Sea and so on could struggle a lot with ballast water management, because it's a long distance to come to the high seas where it's possible to do shifting. And there are some companies that try to help with mobile facilities when they get problems and you have untreated ballast water on board instead of sailing all the way out to high seas. And there's also increasing the emissions, energy consumption, and that is also something that IMO has focused on. Do you ever get any questions on how could you receive our untreated ballast water, or what should we do? Because that is a problem I see when I try to give guidance to ship owners and captains.
Good question. If I can start with, if we get the question, almost never. But I think also that when a vessel comes to the port, it's different kind of vessels, but let's say normal time for a vessel in the port, maybe 12, 24 hours, something like that. And if you have a lot of ballast, it's maybe not time enough to discharge it or do some things about it. So I think, and I'm also pretty convinced that the best thing is if you can deal and treat the ballast water onto the vessels. Because I don't think it will be a good thing if maybe the vessel need to stay for 2 days in the port to be able to have enough time to discharge the ballast and so on. So I think we are struggling a little bit about the time there. So, but no, so almost no questions at all.
Thank you. Do we have any more? Yes, we have one question there and one more.
Thank you. David Eugenius, Gothenburg University, and I'm a doctoral student looking specifically into just-in-time arrivals. So I'd be very curious to hear if you have had any uptake on. I know that you recently started it, but has there been many ships wanting to use it so far?
We have, if we see in the system that we have built, we are still creating that and adjust it a little bit and so on. But in Gothenburg now there is 2 big refineries, and they, like an outcome of this, they almost, not every voyage, but a lot of the trips and voyages that the ship are doing, coming to Port of Gothenburg, they do it in just-in-time phases. So there is company, I think I saw one from, okay, but they coming from Finland, and maybe they will, go from Finland in ballast and coming to Gothenburg, and they see, okay, when will the jetty be ready? So they go into this just-in-time thing, yeah. So a lot of trips go into that way, but not everyone is mentioned in our system.
Thank you. And one last question from Jane.
Yes, thank you very much for the interesting presentation. So I want to ask about port waste water treatment plants. The Trelleborg port and the port of Ystad are the 2 ports that possess port-based treatment plants that treat wastewater before channeling to the municipality. So is that something you think the port of Gothenburg could adopt in the future, or have you considered that as well?
I'm not.
That is for the cruise ship, for the
yes,
passenger
for
ships?
treatment of wastewater. Now the port of Gothenburg receives wastewater from ships and channels to the municipality for treatment. So, but there are some ports already in Sweden possessing pre-treatment plants for wastewater already at the port, before channeling to the municipality. So is that something the port of Gothenburg would like to look into, or have you found any necessity to consider that in the future?
Not as far as we are now. We haven't seen the necessity to that or any need for that.
I can also give an answer here.
Yeah, because they connect to the system.
It's not voluntary that Trelleborg and Ystad stand that. It's because the communities have not they have not the capacity, so they have said no to taking that. But according to the law of water and sewage in Sweden, it's actually not a port thing to do.
No.
So the communities should do it. But the ports in Trelleborg and Ystad have had to do it themselves. So it's not a way to, you shouldn't want to go there. It should be taken care of in the community. So I think you need to leave in 4 minutes, and
Yes.
we need to wrap up this place, this
Yes.
thing. So thank you very much, Don Erik. No, I don't need that one. Summary and final words, it says here. Åsa Burman Lighthouse. But we have done this, as I said, in a collaboration with Chalmers and IVL. So I would like Ida-Maja Hasselöv and Erik Ytterberg and Erik Fridell to help me summarize and say some final words. And we can maybe use those microphones. At least Ida-Maja knew.
But I can relax after I have started.
Yeah.
Right. Yes, I can start to say what an impressive amount of knowledge and information that we have heard today. And what I will bring with me are from the last section here, all the good examples. And I will track you down afterwards, Claes, to get all the figures correct, because such statistics on onshore power supply, etc., there is something that I hope that we can join forces and help you in your protests. So I think that's great with all the good examples that we could also help to promote. So I start there. Bye. Hand over to Erik.
Thank you, Ida-Maja. Yes, I think it's been a very interesting day. I learned a lot about the different effluents that go into the water, and I'm very glad that many of the presentations we heard, you're trying to assess what is big and what is small, so that we really can work on the big problems first. And one other thing I thought about is what Claes said, that I don't remember exact wording, but he said it was like a piece of cake to meet all the regulations. So maybe they are not stringent enough, I was thinking. Maybe we can work on that. And I was going to say one final thing. I forgot. I'll come back to that.
Okay, maybe I will say it. No, I really enjoy being at these kind of seminars where we can meet both researchers, policymakers, and the industry sector, because that's not so typically that you attend these kind of seminars. And also from our perspective, when we are assessing antifouling coatings, we paint like these small dishes and expose them statically in the harbors, etc. And by meeting industry representatives like here and elsewhere, that is very valid for us as well. So then we can work together with the industry and also get some feedback from what policymakers is actually needed. So that's a big thanks to Lighthouse. Yeah, thanks.
Thank you. And Erik, now.
Yeah. Now I remembered. It's very wise. I've also been working with scrubber problem for many years, and I was thinking about that today too. That maybe I would wish that this whole industry, and especially IMO, could change to a position where you actually do an assessment of the technology before you allow them to be used on ship. That would be much better for the environment, also much better for the industry. Like Claes said, that 10 years ago they were promoted from Brussels, the scrubbers, and now you're not allowed to use them. And it's the same with many technologies. I would wish that there were better assessments beforehand.
Okay, thank you very much. And if I could add something to scrubbers, it's not a new technology. Some of us in here are chemical engineers, and scrubbers, that's a unit operation. And so it's been known on land, like a lot of other things have been known, used in other, not at sea. So there was a lot of information about a lot of things prior to that. And I would like to say thank you very much to the audience, to all speakers, and also to my colleagues, Elin, who has been doing a lot of things with the microphone and planning and everything else, and Lasse down there, who is actually not feeling very well, but he's been here today because we don't have anybody else who can stream. So thank you, and hope you haven't been too close to him, all of you. And this is probably, or maybe, the last seminar that I will moderate at Lighthouse. So I would say thank you to all of you that actually have been to some of our seminars and have bared with me. So thank you very much, all of you. And last but not least, I would like to, could you stand up again, Andreas? So, since I'm one of all the senior advisors in this room now, this is the new director of Lighthouse since 1st of October, same day as Erik Ytterberg started at IVL, actually. And do you want to say something? I think it's on.
Hello, yes. I'll also say thank you to all of you, and I totally agree with Eric that this kind of seminars or events that when we can meet both industry researchers and the different agencies, governmental agency, is really good. They should be not too scientific and not too commercial, I think, and I think we balance that quite good today. So this is something that Lighthouse, of course, will continue with, and also will continue moderating, even though she...
Will she?
Maybe she will. You're doing a great job, so thank you for that. And I think also that I have learned a lot, and I think sometimes you need to look back in time to actually see the progress that we are doing. We are doing great progress within the shipping industry, I think. We have great ship owners in Sweden that actually moves ahead of legislation and finds a way to finance it and also make some good money on it. And that's really impressive, I think. A long time ago when I was working at sea, when we cleaned out the compartment where we have the paint, we just threw it overboard. So, I mean, that's not even on, you don't do that anymore. It's not on anybody's mind. So I think in many ways we are coming forward, and we need the research and we need the industry to keep evolving all the time. So thank you all for being here.
Thank you.